Hello students, welcome to Aditya Academy. I'm Dr. Ragini Arora and today we will be doing exercise 1.2 from chapter Real Numbers. Right? Before that, I will just give you a recap of irrational numbers. What are irrational numbers? Numbers which have decimal representation of type non-terminating and non-recurring. Right? What is the meaning of these terms, non-terminating and non-recurring? So let us have an example like 7 by 3. Like decimal representation is, to convert this rational numbers into decimals, we divide 7 by 3. 3 2s are 6, 1, decimal 0, 3 3s are 9, 1 0 and 3. So you can see that this division goes on till infinity and it never stops anywhere. So we can say that 7 by 3 can be written as 2.333 dot dot means infinite times. So this can also be written as 7.3 is equal to 7 by 3 is 2.3 bar. So this decimal representation is called non-terminating. Non-terminating. And since it has a number which is repeating for infinite times, so we called it recurring. Recurring means repeating. So we can see that since this division is not ending anywhere and a single number or a pattern of number keeps on repeating, then we say it recurring. So this decimal is called non-terminating recurring type decimals. We can also see that such numbers can be written as rational numbers. Means the decimal of types non-terminating but recurring can be expressed as a rational number. Right? So now we come to this point. We have learned what is non-terminating means, a decimal which never ends anywhere. And this was an example of recurring type. Now, if we take the square root of 2, we had done this in class 9, so I will not be solving it here. But the values was root 2 is equal to 4142 and dot dot. This was non-terminating decimal. And another thing is, there is no single number or a pattern of numbers which are getting repeated in this decimal representation. So this is non-terminating. Non-terminating, that means it is not ending, non-terminating and non-recurring. Non-recurring means there is no set of numbers which are occurring in repetitive manner. So this suits to the definition of irrational numbers. That is why we say that root 2 is irrational by the definition of irrational numbers. Right? This has non-terminating, non-recurring type of decimal representation. So root 2 is irrational. Similarly, root 3, root 5, root 7, root 6, all those square roots and cube roots of numbers which are not perfect squares or cubes, those are irrational numbers. Then one more important thing, that these irrational numbers, these root 2, root 3, root 5, we cannot write them into the form of p by q. Right? So they are not rational. They can never be expressed in the form of p by q. So they are irrational. We had learned in the first video that set of real numbers is a universal set in which we had a set of rational numbers and a set of irrational numbers. And you can see here that rational numbers and irrational numbers are two disjoint sets. That means they have nothing in common. They are a separate set of numbers and they are a separate set of numbers. They cannot be mixed with each other or they cannot be written in the form of each other. But these irrational numbers can be represented on number line. They can be represented on the number line, right? And we had learned all these things in class 9. So it was just a recap of irrational numbers because we will be using these numbers in the exercise that we are going to do now. So the first question of this exercise is prove that root 5 is irrational. Now in class 9, we had done this presentation by taking the square root of these numbers. Square root of these numbers in long division form. But now we are going to do it in contradiction method. What is contradiction method or contradictory proof? Contradiction method is we have to prove that root 5 is irrational. So we are assuming that, let us assume that the square root of 5 is rational. Contradiction is something that we are assuming the opposite of what we have to prove. We have to prove that root 5 is irrational. I am assuming that root 5 is rational, and after the calculation, I'll prove my hypothesis wrong. Let us assume that root 5 is rational. So by the definition of rational numbers, I can write root 5 is equal to a by b, right? Where b is not equal to 0. And one more thing you have to assume here, that HCF of a and b, HCF of a and b is 1, right? This is considered as equation 1. So this is our hypothesis that we are assuming root 5 to be rational with the common factor of a and b as 1. Now we solve it further. We transpose b to left hand side. It becomes root 5b is equal to a, right? Now squaring both sides. We get root 5b whole square is equal to a square. Solving this, we get 5b square is equal to a square, right? So try to understand this thing, like a square is equal to 5 times b square, right? That means a square can be written as product of 5 as well as b square. Let us assume that 10 can be written as 2 times 5. So what we can say is 2 divides 10, 5 also divides 10, right? So when we write a number as a product of its factors, each factor divides this number. So here 5 divides a square, b square divides a square. We are just concerned with 5 here. So I can write 5 divides a square. A square is equal to 5b square. So 5 divides a square. Now I'm further taking this example, like 5 divides square of a number. Right? 5 divides, let's say, square of number means 5 divides 100. That means 5 divides square of 10, right? So you can see that 5 divides 10 also. So if a number divides square of a number, we can say that this number will divide 5 divides a also, right? So if 5 divides a square, 5 divides a. Now if 5 divides a, that means a is a multiple of 5, right? A is a multiple of 5. That means a can be written as 5 times something. That a is equal to 5 times some number m, right? 5 divides a means a is a multiple of 5. A is a multiple of 5 as a is equal to 5m. Now again squaring both sides. Squaring both sides. This is a square is equal to 5m whole square. This is 25m square, right? So we had assumed this as equation 1, consider this as equation 2 and this as equation 3. What we have got is a square is 25m square, right? But in equation 2 we had got a square as 5b square. So I'm substituting the value of a square from 2. This is 5b square. See, we have developed a relation between a and m. Now we are trying to get the relation between b and m. So by substituting the value of a square, I got 5b square as 25m square. Transpose this 5 to right hand side, we get b square is 5m square. So now again we have got the same kind of thing. A square was 5b square, so 5 is a factor of a square. Here 5 is a factor of b square. So we write 5 divides b square. So 5 divides b. The same way we done with a, right? So 5 divides b square, 5 divides b. Now write this as equation 4. Now see, 5 divides a, 5 divides b. So we can conclude that 5 divides a and b both from equation 3 and 4. That means 5 is a common factor of a and b. But see, what we had assumed in the beginning, that common factor of a and b is 1. That means they have no common factor other than 1. But now after the whole process, we have proved that 5 is a common factor of both the numbers. So this is contradiction to our assumption. Contradiction to our assumption. Therefore, we can say that square root 5 is irrational. Right? These are called contradictory proofs. So you need to practice this twice and thrice by learning the way we have proved them. Similarly, we can prove root 2, root 3, root 7, root 6, all these numbers irrational by the same method, right? But in this chapter, for the further questions, we are taking into consideration that root 5, root 2, root 3, all these are irrational numbers. So next question needs to prove that 3 plus 2 root 5 is irrational. Here the start will be the same. Let us assume that 3 plus 2 root 5 is rational. Same contradiction method. So by the definition of rational numbers, we can say that 3 plus 2 root 5 can be written as p by q, where q is not equal to 0. But in this case, we don't have to do that much or elaborated proof. We know that root 5 is irrational. So in all the questions, what we will be doing is, we will be keeping the irrational number on one side and rest of all the integers on another side. So 2 root 5, first of all, I transpose 3 to the right hand side. P by q minus 3. By solving this, I get p minus 3q by q. Right? So we have brought 3 to the right hand side. Now again we have 2 with root 5. It is in multiplication. So when we transpose it to right hand side, it goes into division. It becomes 2q in the denominator. Right? So our purpose was to bring all the integers on one side and an irrational number on the other side. That we have done. Now we know that p and q are integers. Therefore, RHS is a rational number, right? A rational number. But root 5, square root of 5 is irrational. Then we can say that a rational number cannot be equal to an irrational number. So we can say that our assumption is wrong and 3 plus 2 root 5 is irrational. Right? This is the method, and we will be using the same method in all the questions of this exercise. We have to keep an irrational number on one side and rest of all the integers on the right hand side. So our next question is, we have to prove that 1 upon square root of 2 is irrational. So we will use the same method. Let us assume that 1 by square root of 2 is rational, right? So by the definition of rational numbers, we can say that 1 upon square root of 2 is equal to a by b, where b is not equal to 0, right? Now, by cross multiplication, we can say that square root of 2 times a is equal to b, right? Now again, the target is same. We have to bring only irrational number on one side. So keeping root 2 in the left hand side, we take b to the right hand side. Sorry, a to the right hand side. So it becomes square root of 2 is equal to b by a. So here we know that root 2 is irrational. We can write a and b are integers. A and b are integers. So RHS is a rational number, right? A rational number. But square root of 2 is irrational. So we can say that a rational number cannot be equal to an irrational number. Cannot be equal to an irrational number, right? So we can conclude that 1 over square root of 2 is irrational. Our hypothesis is incorrect. We can say that 1 by square root of 2 is irrational, right? Now the next number is 7 root 5. So let us assume that 7 root 5 is rational, right? We can consider that this is a rational number. So by the definition of rational numbers, 7 root 5 can be written as a upon b, where b is not equal to 0. So we just have to perform one step in this question, that is take 7 to the right hand side. It becomes root 5 is equal to a upon 7b. So we know that square root of 5 is irrational, right? Irrational. A and b are integers. So RHS of this equation, RHS is a rational number. And since we have an irrational number on one side, a rational number on other side, they cannot be equal. A rational number cannot be equal to an irrational number, right? Irrational number. Therefore, we can say that 7 root 5 is irrational, right? So, we have got our proof. Next is a question. This is 6 plus root 2, and we have to prove it irrational. So, let us assume that 6 plus square root of 2 is rational, right? So 6 plus root being rational can be written as a upon b, where b is not equal to 0. So now we have to transpose all the numbers to right hand side. We have only 6 here. So square root of 2 is a over b minus 6. So we can say that square root of 2 is equal to, take b as LCM, a minus 6b. So we are done. We know that square root of 2 is an irrational number. A and b are integers. So RHS is a rational number. RHS is a rational number, right? A rational number cannot be equal to an irrational number. So we can consider that our assumption is wrong. We can say that 6 plus square root of 2 is irrational, right? So this was all about this chapter. We have finished both the exercises of NCERT. I hope you enjoyed these 2 sessions. So I hope you liked watching my video. Thanks, and please do not forget to like and subscribe and share this video. Thank you so much.